Okay, so we are going to finish the section 2.1 packet. We left off on page 6. I'll also, for those, if you weren't in class, I'll post section 2.1 notes on Moodle. Okay. All right, so here in example 7, we need to write the standard form of the equation of the parabola whose vertex is -411 and passes through the point -615. So since the vertex is -411, then we know that's our h and that's our k. And it passes through the point -615. So we know the standard form is a function f of x equals a times x minus h squared plus k. And so this is going to be our x and f of x. All right. And so we can fill in the information we have so far. So we know that f of x will equal a times x. Now here's the thing. Since h is -4, then we can write it as it's x minus -4 squared plus 11. But of course, we know we can simplify that to a times x plus 4 squared plus 11. Okay, and so note here, just a little side note, since that is plus 4, then if you were given something in x in standard form and it was x plus 4, x plus 2, x plus some number, then you know the h is going to be negative because the standard form is negative. So if you have a negative number for your h there, then that means when you place in the standard form, it's going to be x plus that number. Okay, and I hope that made sense. You'll have some practice problems in class. And so now we have our h and our k, and now we need to find a, right? Well, we're given a point. That's why we're given a point. F of x equal x and f of x -6 and 15. So 15, I don't want the highlighter. So 15 equals a times -6 plus 4 squared plus 11. And you just simplify that. So that's 15 equals a, that's going to be -2 squared plus 11. So 15 equals 4a plus 11. And so if we subtract 11 on both sides, we get 4 equals 4a. And so a equals 1. And so therefore our standard form will be f of x equals x plus 4 squared plus 11. Okay, so this is still on the same page, but I had to go to a different slide since I'm doing this in the video. And so the vertex is always the highest or lowest point on the graph, okay? And that tells you, in terms of quadratic functions, that can tell you a lot, especially with applications. So the y-coordinate of the vertex, in other words, the k, because you know the vertex is usually given as hk. So the y-coordinate is always the maximum or minimum of a function. And in fact, the hint on the left-hand side, you actually will know the max or the min of the parabola by knowing if it opens upward or downward. If the parabola opens upward, then the vertex will have, so if the parabola opens downward, the vertex will be the maximum. Okay, you can sort of see that, right? If it opens downward. And if it opens upward, then the vertex will be the minimum. Okay, another nice tip is that if the function is written in the form f of x equals ax squared plus bx plus c, You can find the max and the min values in this following way. Now, remember, you can always complete the square. If you forget this formula, and that's why I show you the formulas, but in case you forget it, I still want you to know how to complete a problem, even if you forget the formulas, because I don't teach to formulas. I teach to the concepts. So if you had this form here, then you know you can complete the square and get it into the standard form, and then you can clearly see your vertex. And then this A, remember that A will tell you if it's positive, then it's opening upward, which means you have a minimum. And if it's negative, it's open downward, which means you have a maximum. Okay. So, however, there is a formula. So if you don't feel like completing the square, when A is greater than 0, we know we're going to have a minimum because it's going to be opening upward at negative B over 2A. That's the X value. So the X value is going to be negative B over 2A. And the minimum value is going to be F of whatever that X value is, which is F of negative B over 2A. Okay, so this is an easier way to find your min and your max without having to complete the square. Now, if your A is less than 0, then that means you're facing downward and you're going to have a maximum at that same point, negative B over 2A. So it's really dependent upon if you're opening upward or downward to determine whether you're going to have a max or a min. And again, that max minimum value. Oh, I'm sorry. That should be maximum. So change that to maximum in your notes. Will be F of negative B over 2A. Okay. And so in essence, another way to find your vertex when it's in this form is just to do negative B over 2A and then F of negative B over 2A. Okay, so in example 8, we're going to use the formula, and you have it all on one page, but I had to go to a different slide for space. And so here, notice that let's write our A, B, and C values, just because we don't even need our C values, but let's just write it. So, and these are the coefficients in front of our different terms. So that's going to be A is 1, B is 2. So when there's really not a coefficient, is always a 1 there. B is 2 and C is 1. Okay, and again, we don't need C, but that's just for knowledge. Since A is greater than 0, then we know we're going to be opening upward, so we're going to have a minimum. Okay, and so X, remember X is negative B over 2A. So that's going to be negative 2 over 2 times 1, which is negative 2 over 2, which is, 2, which is negative 1. Okay. And then, so that's your X value for the minimum. And then you can plot, so F of negative 1 is going to equal negative 1 squared plus 2 times negative 1 plus 1. All right. So we put back in that's our G of X. Oh, I should have changed it. I'm sorry. This is our G of X. I switch up letters, but don't let that bog you down. Okay, so G of negative 1. All right, and so that means the minimum point. Well, you can write it at the point or just say the Y value. So minimum at negative 1, 0, because this is going to give us 0. That's going to be 1 minus 2 plus 1. Okay. Okay, so the last problem on the notes, and then like I said, we're going to start. So if you weren't in class on Friday, you need to get the notes from someone to get the first half of the notes. And what we're going to do when we come back to class on Wednesday is I'm going to have a worksheet for you guys to be working in groups on that will be due in class by the end of class. Okay, so let's look at this last problem. And this is the application. So this is talking about revenue. So the total revenue earned per day in dollars from a babysitting service is given by this function here. R of P equals negative 12P squared plus 150P, where P is the price charged. The price charged, it says charged, not charged, it's charged per child, okay, in dollars. A says find the revenues when the price per child are $4, $6, and $8. And then B is find the unit price that will yield a maximum revenue. What is the maximum revenue? Explain your results. Okay. And so looking at A, hopefully you guys should know how to do A. You just plug in for the different values because P is representing our price, right? Charge per child. So we look at R of 4. And what I would advise you to do is pause the video now and see if you can figure out the values. I'm just going to give you the answers. You should know how to input functions now, so I'm just going to save time, give you the answers. But pause and see if you get the same answers, or, you know, if I did something wrong, let me know if you're getting something different than my answers. Okay. All right, welcome back. So R4 is going to give us, should be a $408. BR of 6 is $468. And then CR of 8 is $432. Okay. And then, so B is saying find the unit price that will yield a maximum revenue. And we know it's going to be maximum how? Well, you should see that negative sign there, that's a negative 12. That negative 12 tells you that the parabola, this is quadratic function, the parabola is going to face downward, which means you have a maximum. So we know we're going to have a maximum, and the maximum revenue is at the vertex, just like the minimum is also at the vertex if that was positive. So your maximum or minimum prices for quadratic functions will always be at your vertex. So remember that. So that means we can use our x equals negative b over 2a and then f of negative b over 2a to find our vertex, and then that'll give us the information that we're looking for part B. Okay, so A is negative 12, B is 150, and we don't need C, but C would be 0, right? Because there's no constant term there. Okay, so X is negative 150 over 2 times negative 12, so that's 150 over 24. All right. Which is, once you simplify that, you should get 25 fourths, if I simplify that correctly. Okay. And X is really P. So I should have said, I actually should have had this as P. I want to be consistent in my terms. So P is actually equal. Yes, let me change that. So that's P. And so P is equal to $6.25. So that's the maximum price that you should charge to get the maximum revenue. And with that maximum price of $6.25, then let's see what we'll get. Well, F of, I'm going to put in the 25 fourths. And again, pause and see if you get the same answer. And I believe you should get $468.75. Okay. And so in terms of explaining your results, you can write this down. I'm not going to write it down, but you should write it down. So what this is saying is this. My maximum revenue, you would think the more you charge per child, the more money you should make, right? You would think that. But this function is a little different because as you can see, well, I did make more money going from $4 to $6, right? But when I went from $6 to $8, I went down. So, I mean, you can sort of conjecture why might that be the case. But basically with this quadratic function we're given, what this is saying is that in order to get your maximum profit, you should charge $6.25. And your maximum revenue with this particular function is going to be $468.75. So that's the meaning of that. Okay. So feel free to go back over this. Make sure you go back over the first half of your notes as well. And like I said, on Wednesday, when we return back, I'll give you guys a worksheet to work on.